It's a pleasure to be here this evening. I give a lot of presentations, usually for investors, but I very seldom get to speak about geology. So it's a real delight when I get a chance to talk rock. This evening, what I'm going to do for you guys is I'm going to present a history of Novo, which is the company you see here on the screen, and our efforts to explore for conglomerate-hosted gold deposits in the Pilbara region here in Australia. Novo was started about 8 years ago. I actually started this from the ground up. It's a Canadian-listed company, and we started on really a conceptual basis. There were conglomerates known in the Pilbara, Nullagine up near Barnable Bar. There were some, but the whole notion that there could be gold-bearing conglomerates of significance in the Pilbara really has taken shape just over the past couple of years here. I'm going to give you kind of a chronological picture of how this story has unfolded. I also am acutely aware that the story here in Australia is met with mixed review. A lot of people think, what on earth is this? What the heck are these guys doing here? This deposit is a geologic freak. It's very hard to get one's mind around it. But I'm going to show you tonight where we're at with the project and where I think we're going to be able to take it going forward. Okay, so you can see here a little bit about the corporate structure of Novo. We are Canadian listed on the TSXV. We have a little over 150 million shares out. Yes, you're reading that correct. Our market cap is nearly $1 billion. Even I am astounded. I mean, this is crazy. You know, $1 billion valuation for a project that is very, very speculative. All right, but the reason it is as high as it is for just that. It's speculative. If we are correct, it could be a significant gold deposit. It could change the gold mining industry. That future is yet to be determined. With options and warrants, we have about 200 million shares out. Fortunately, we have about 68 million in cash in the bank at the moment, which is going to allow us to do a lot of the heavy lifting that's required to move this project forward. You can see our shareholder registry in the pie chart. Newmont remains a large shareholder. Newmont came in 2013. I used to work for Newmont. When I picked up the projects, they knew a lot about the story because I actually started looking at this possibility back in 2004, so roughly 14 years ago. And you know, when I left Newmont 2007, I kept close touch with all the folks. And as I developed the company and the projects, they took part. You know, they took actually a very large shareholding back in 2013. They started out at around I think it was around 35 or 40%. They've been diluted out. They did sell part of their interest to Kirkland Lake in September of last year. Kirkland Lake in the purple is our largest shareholder at present. They're a little over 16%. Actually, that's increased. This pie chart's a little bit out of date. They're currently at about 18.5%. They just bought, I think it closed yesterday, but they bought 4 million shares that were held by a junior company, of our shares held by a junior company. Mark Creasy, you see in green, a long-term shareholder. He's the one that actually helped me get a lot of the land put together in the first place. That's how he got his position. Anyway, you can see, fairly tightly held company. The people involved, I'm the chairman and the president. Rob Humphreys, who I'm sure many of you in this room know, I asked him to become CEO about a year ago today, so he's His first anniversary is this week. Eric Sprott, well-known financier in Toronto, is also a director. Eric has put up a lot of money over the years to help support me with the effort to look for these deposits. He was rewarded, fortunately, last year when we made this discovery at Ker Arthur, and our stock price has nearly gone up tenfold over the past year or so. Greg Gibson is part of the Sprott Group. He runs, he's actually CEO of Sprott Mining, which is a private entity that Eric owns. Akiko Levinson is a mining entrepreneur I've worked with for many years. She's been on the board of directors from the very beginning. Michael Barrett lives in Perth. He's a finance background. He also has strong connections in the Perth mining scene. Some of the names you'll see here, again, you'll probably recognize. Simon Pooley is our COO. He was with Millennium up until joining us a couple of years ago. Ronan is Canadian. He's our CFO. Leo is also Canadian, in charge of corporate relations. Chris O'Brien worked for Newmont and other companies. I think he undertook the Tanami expansion a couple of years ago. Anyway, Chris has joined us. He's a project director, and he's overseeing a lot of the technical work we're doing right now. Another name that's probably familiar to many of you is Kaz DeLuca. We got Kaz out of Newcrest, actually, at the first of the year. She is now our general manager of exploration. I can't be more delighted to have very, very skilled technical people in our team. Okay, so why do we explore in the Pilbara region? Well, I got to start about 3 billion years ago. Here on Earth, there was very little continent on Earth at 3 billion years. Really, just one significant landmass was present. It was called That's one of the terms. Another term you might hear is called Valbera. It's a combination of the word Capval, as in the Craton in South Africa, and the Pilbara here in Australia. But is probably a more common name you'll see. Was about the size of the country of New Zealand. That little piece of landmass has since broken apart and become the core nuclei of various continents around the world, including the Capval, like I said, and Pilbara. There's also bits of it in India and even a small fragment in Brazil. But that is basically where the stage was set 3 billion years ago. You did not have a lot of continental landmass to work with at that time. All right, so the reason we're here is because there was a major gold event on that little continent. It's expressed in South Africa as the Witwatersrand Basin. Huge inventory of gold. About 1.6 billion ounces have been mined, roughly another billion ounces in reserves and resources. That's in the Capval. I figure, well, if that gold was deposited on that end of that continent, perhaps the Pilbara end of that continent also might have the same potential. What you're looking at here, and I realize you cannot read a lot of this strat column. I'll zoom in on a bit of it here in just a second, but this is a comparison of the stratigraphy of the Capval Craton on the left and the Pilbara Craton here on the right. In the middle, you have a time scale. So you can see there's 3 billion years, there's 2.5 billion years. It's a correlation. It shows the correlation of stratigraphy from one craton to the next. We're going to zoom in on that area right there. And we're going to see how rocks in South Africa, these are strata that are present in and around the Witwatersrand Basin, the Capval Craton, compare with the rock and strata that we have in the Pilbara Craton. First of all, you can see there's a profound unconformity at around 3 billion years. And below that, in both cases, you have debasement rocks. These are the rocks that form the core of the Pilbara and the Capval Cratons. Above that, you have sedimentary rocks. These are the first siliciclastic basins that really formed on this planet. In South Africa, you have the West Rand Group. Over here, we have what's called the De Grey Group, and it's seen in bits and pieces across the Pilbara region. Now, this group here, Central Rand Group, is what hosts most of the gold in conglomeratic deposits in the Witwatersrand Basin. Notice there's no correlation. There's no correlative unit here in the Pilbara that equates to the Central Rand. we essentially have a period of folding and thrusting and exhumation during this time interval. That's interesting. All right, so I can tell you right now, we've looked hard and we have not found central rand equivalent rocks on the Pilbara. All right, but what we do have is this sequence of rocks above. In South Africa, you have the Ventersdorp sequence right here. There's a very important gold event at the base of the Ventersdorp. It's the Ventersdorp contact reef. And I would say that is the best correlation we can draw with what we see in the Pilbara craton, which is at the bottom of the Fortescue group. These are gold-bearing conglomerates right at the bottom of the Mount Royal basalt, but also up into the Hardy Formation, which is a sandstone sequence above this basalt. All right, so these two appear to correlate fairly well, and this is the regime that we're exploring, and this is where we're looking for our deposits. All right, so back in 2010 when I got Novo going, we came to the Pilbara, and this is really a snapshot of what was known about conglomeratic gold in this region at that time. The best known occurrence was at Beatons Creek, which is near the town of Nullagine, which is about 200 km north of Newman. There were also gold occurrences in conglomerate at the Just-in-Time and Tassie Queen mines near Marble Bar. Both of those areas have historic production. There was a bit of gold known out here at Egina, but nobody was able to put their finger on the actual source of the gold. It was all alluvial gold that was speculated to have been derived from conglomerates. There was a bit down here at Tambina. Look, I won't go through the rest, but there were a few scattered gold occurrences, both in the sub-Mount Royal environment and the Hardy Formation across the Pilbara. All right, where we started was actually at Beatons Creek. This is in the East Pilbara. We picked up Mark Creasy's ground, but we also picked up some ground through a joint venture with Millennium Minerals. This is the Beatons Creek property. We've since bought out Millennium's interest in the Beatons Creek project, so we own this 100%. Surrounding ground is Mark Creasy's. What we saw at Beatons Creek was a series of stacked fans. This is a basin, a sub-basin coming off the Hammersley Basin, in which a series of fan deposits, fluvial deposits, were deposited in a fairly shallow marine environment, and they were reworked over time. So the geologic model for this area is shown in these diagrams here. You basically have a prograding alluvial fan. During a low stand, the fan is able to develop and propagate out into the sea. But over time, as sea level rises occasionally, the wave action cuts into the fan, and it basically condenses a lot of that material, especially the gold, onto a transgressive lag deposit on the seafloor. So you get this interaction between a fluvial system and a marine system, and they go back and forth, just like a gold pan, just like shaking a gold pan. So the gold gets concentrated, if you will, over time along that ocean margin. What we see at Beatons Creek are things like this. Here you can see channelized deposits. You can see the kind of the smiley face structures here. This is the fluvial type system, but occasionally these are punctuated by flat horizons, which are the lag horizons. So again, you get this interplay between fluvial and marine deposits. Further from shore, the transgressive lag deposits take hold, and you get these very flat, continuous sheet-like deposits. These are more similar to what you see in South Africa. The one difference, though, is that these are boulder conglomerates. These are what I would call quartz boulder conglomerates rather than quartz pebble conglomerates like that you would see in the Central Rand unit. All right, but nonetheless, these are quite rich. Gold is concentrated within the matrix of these conglomerates, and they're very predictable. They underlay square kilometers, so they're a very attractive target. We've actually drilled up a resource here at Beatons Creek, a modest resource of around 600,000 ounces. And we're about to undertake on a new effort now that we have a better understanding, actually, from what we've done at Karratha. We're looking at going back. I'll talk more about that later. Here's some close-ups of the Beatons Creek area. There's an outcrop of the conglomerate horizon. It's about a meter thick, maybe a meter and a half thick on average. You can see the size of the boulders. Oftentimes they're over a half meter across. They're mostly siliceous material, either quartz vein, or some other older silicious rock of some sort, chert or something. All right, but they tend to be rounded and very, very hard material. The gold occurs in the matrix, the sandy matrix between the boulders, and you'll see these black pitted areas. These are actually after oxidized pyrite. All right, so there is detrital pyrite in these conglomerates, and that pyrite, when it's oxidized, forms these dark pits. Invariably, though, when we see a lot of pyrite like this, you also get lots and lots of gold. So this is a piece of weathered matrix from which this gold in this picture right here in the bottom, if you can see it, has been panned. What else do we see at Beatons? Well, we got different forms of pyrite. We see porous pyrite, we see compact pyrite. These are the kind of things you would see in the Witwatersrand. We also see carbon, actual particles of carbon within the conglomerates. Again, very similar to what's seen in South Africa. This little piece in the corner, that's actually carbon that's intergrown with uranium and thorium, also termed thucolite, which is a term that was coined in South Africa. It's an acronym to describe carbon that's rich in thorium, uranium, and so forth. Anyway, that's very, very similar to what you'd see in South Africa. At Beatons Creek, we have two types of gold. We have coarse gold like this, up to maybe 2 or 3 millimeters across. But we also have a fine component of gold like this. And it's these two different styles of gold that are telling a tale here. This is probably truly alluvial gold. This is gold that's been washed into the basin with the conglomerate. Whereas the fine gold here it's often crystalline, it's very hackly material. It's very fine grain too, on the order of 20 microns. This is not the kind of gold you would get concentrated in an alluvial regime. So it's probably grown in place. And without going off into a whole tangent here, I've done a lot of work on the background of gold such as this in South Africa, right? My view is that a lot of gold that you see like this is actually precipitated out of seawater at the time of deposition. All right, so the first 6 or 7 years of Novo's history was focused in the East Pilbara around Beatons Creek and Marble Bar. But I'm now going to jump rails here, and we're going to talk about the Karratha region. The city of Karratha is here. This is the Karratha Gold Project as it presently stands. Everything in green is 100% Novo. We have joint ventures with Artemis in purple. We have a pink area right there called Comet Well, which is also a joint venture with some prospectors in the Karratha region, and another joint venture with Welcome Exploration in orange right there. But we assembled this land package in about the past 18 months. Now I'm going to tell you why. In late 2016, I was in Nullagine. We were working on Beatons Creek. Some of the prospectors in town, I was having a beer with them after working one day, and we were sitting around the fire. They told me, people are finding heaps of gold out by Karratha. So news of a new gold discovery spread quite quickly, and people were finding, literally with metal detectors, lots and lots and lots of nuggets. Now, the photos you see here are exceptional. Okay, most of the nuggets were not like that. Some of these are up to 1 kilo. I think this one here is 1 kilo. But there were a few nuggets found like this. Most of the gold is like this. It was a very distinct, rounded, what I've termed melon seed. Look, it's, I feel like I should have trademarked the term watermelon seed, because I could have made a fortune of it. But anyway, it's actually been used in literature too. There was old papers describing melon seed gold at Egina, for example. Okay, so it's nothing new. It was just meant to describe water-worn gold nuggets. But people were finding these in soil, and I started to do a little investigating. Fortunately, I had a very close friend who provided a little information to me. Anyway, without divulging who that was, he showed me a picture from a news release from Artemis Resources. This was issued in February 2016. That is a gold nugget. You can just see it's distinctly dimpled. Almost all of the gold that's found at Karratha has this very distinct dimpled surface, probably partly from the impression of the matrix, the sand grains upon the gold during burial, but also to a certain degree recrystallization. So anyway, it's a very distinct pattern. You can see this is clearly a water-worn gold particle, but it's been derived from rock matrix. Right? That's quite interesting. He told me, this is coming out of Conglomerate, told me to read this news release when Artemis published it. As soon as I read it, I called up my exploration manager in Perth. I was in Denver. It was snowing like mad. It was the middle of the night. I said, look at what land is available down dip from Artemis into the basin. He calls me back in half an hour later. He says, it's all open. I said, start staking. Don't stop until I tell you. We started staking ground around, I think it was February 20th, 2016, or 2017, sorry. I was wiring $100,000 a week down to Perth so these guys, my team, could keep staking ground for about a 9-week period. We just staked like mad. And it was all based on what my friend told me and showed me about this occurrence. By the way, it was kind of a last, like a Hail Mary, if you will, too, because we were down to fumes on money. But I felt compelled that this could be what we had been chasing. All right, so the first visit I made to Core Arthur was in April of 2017. We had already staked about 7,000 square kilometers. This is the first site I saw. This is the Kuya Puya dolerite. In the middle ground right here, these are hills of Conglomerate. Never been mapped. Nobody recognized this as Conglomerate. There was Mount Rowe mapped in the area, but nobody recognized that there was a distinct unit associated with Mount Rowe and below it that was actually conglomeratic. But these hills through here were riddled with little holes where people had dug up gold nuggets. People had been going out metal detecting this area for several months prior to this. Really the rush started around September of 2016. So by this time it had been going, about 8 or 9 months. But the ground was absolutely riddled with little holes. This shows one of the few outcrops. You can see most of the topography is quite subdued. It's very hard to see outcrop, but in a couple of places I actually caught a glimpse of Conglomerate. Well, what really struck me, one fellow had a piece of rock with a rounded nugget sticking out. Kind of stuff that makes your hair stand up on your neck. It's like, this looks quite interesting. Somebody gave me a piece of rock. They said, if you crack these rocks open, you can find a nugget inside. I was like, you're kidding me. So I bought this rock and sat there and beat it with a hammer for a bit, and out popped the first in situ watermelon seed nugget I got off this property. And when I saw that, I was convinced there's something more to this discovery. This was one of those moments that just kind of changes one's life. All right, so once I had visited the property, I felt pretty comfortable cutting deals. I approached some prospectors at Comet Well about their land. I talked to Artemis about joint venturing, and while, just based on a hunch, while all of this was transpiring, we were able to secure all that land. So in the background, I was working frantically on the land, and quite frankly, I didn't go back out to site until June, so nearly 2 months later, and that's where I met Rob Beaton. Rob is a prospector. His family's lived in the Core Arthur, or I should say Pilbara region for a very, very long time. Beaton's Creek. His great-grandfather worked, that's where Beaton's Creek was named after. I mean, that was just creepy. It's like, you're kidding me. That's nuts. Anyway, so Rob here, he found an outcrop. He actually found an outcrop, and he was actually hacking off rock. He was detecting nuggets and hacking off rock, and then breaking the rock open and extracting the nuggets. So this is his little muck pile here. Each one of these pieces of rock on the ground has a nugget in it. He would break those open, pick the nugget out, and then he'd chuck the waste in another pile and save it for milling later. But the rock he had in his pile, tell right away, this is Conglomerate. This was the real deal. This is the kind of gold, the watermelon seed nuggets is what he was getting out of these conglomerates. Okay, so at that point I felt very, very comfortable moving forward with some very expensive deals, and we assembled this little area right here. But with that, we completed the land acquisition in July of last year, and we decided to jump in and start exploring right away. We knew we had a coarse gold system, that assaying this material is going to be very difficult. So the first thing we did was dug a trench to try to extract the bulk sample, and we talked to many labs around Perth to find out which lab could come up with the most solid technique for assaying this material. Turned out to be Nagrom. Anyway, this trench that we opened up was maybe about 1.5 meters on a side, so it was about 1.5 meters by 1.5 meters in area. We dug down through about 0.5 meter of skeletal soils and got down to bedrock, at which point the guys metal detected, and then they started jackhammering the rock up, and immediately nuggets started popping up. It was an absolutely incredible moment. Everybody was so excited when this happened that the enthusiasm was very hard to contain. I didn't realize this was going to happen. Long story short, our joint venture partner Artemis found out about the fact we hit these nuggets, and I got an email saying we need to announce this immediately. And I thought, okay, I think we better give the benefit of the doubt and actually issue the videos that were taken. These are actually still shots from the videos when they found the nuggets, along with the news release. When this was published, our stock went from about 80 cents to about $2.50 in about 2 or 3 days. It's very easy to get excited about visible gold. You can see multiple nuggets in this one sample. All right, so we delivered 2 drums of that material. Each drum had around 250 kilos. And we talked to Nagrom. They actually had access to a Steinert ore sorting machine. This machine was to be delivered, I believe, to a goldfields operation or something like this. Anyway, this machine had both an X-ray and a metal detector on it, and was designed to identify particulate gold, metallic gold in rock. All right, so we put the sample through. These are the 2 bins. This is the waste bin, the ore bin, and in 10 or 11 seconds, it processed 500 kilos rock straight into this bucket. Was the concentrate. Every single piece of rock down here in this had a piece of visible gold sticking out. It was amazingly efficient. It took the mass, the whole entire sample, reduced it down to about 2% of the mass, yet captured about 85% of the gold. It was remarkable. After crushing that material and processing it in various ways, Nagrom determined a calculated head grade for the two fractions that we had submitted. The average grade for these 2 was about 2.16 ounce per ton. Remarkable result for an early stage project. But once again, we could tell we have a coarse gold situation here. Now, this fine gold, I thought, might be disseminated through the rock matrix. We couldn't tell because after it's processed, you don't know where it is. Turns out this occurs in a very particular setting within the rock, and I'll talk more about that later, but the coarse gold definitely there. Between July and September, we did detailed mapping from the Purdy's reward area up here down to the Comet well area. This actually continues off the screen for another few kilometers. The yellow unit you see here is a sedimentary sequence that sits below the Mount Rowe. The Mount Rowe basalt is shown in this green color right here, and then the Hardy sandstone is this yellow color through here. But we had a very good geologic map compiled over about a 3-month period in preparation for more advanced exploration work. Our stock price continued to rise, pure speculation, but people recognize the type of system, the type of potential this has. The people who took note was our long-term shareholder Eric Sprott, and this is the CEO of Kirkland Lake, Tony McCooch. They put a $56 million placement into Novo in early September of last year, and that money, I can tell you, I do not like bankers. not having to go to the bankers and ask for money was one of the biggest delights in my life. When Tony called me up and he said, we'll do 14 million shares at $4 a share, I said, where do I sign? All right, but we took the money, and that money is what we're using to explore right now. As a reward, I brought Tony and Eric to site a few days later. We let them metal detect, and then we chiseled up nuggets. This is Tony after he found a few. In about 10 minutes, he found about an ounce of gold out of one of the trenches. Talk about a happy camper. All right, to pull off one of the world's dumbest stunts, we decided to do a live stream from site, and the reason for this was because we felt so confident after doing this many times that we knew every time you hit a signal with a metal detector it was a gold nugget. So we actually opened up a trench here, and we did a live stream during the middle of the night in Australia, but in the middle of the day in Denver. And we broadcast live for people detecting and excavating gold nuggets. It was a nail-biting experience. If anybody's ever watched the video, you'll note that it was right at the last 23 seconds of the session when they found the biggest nugget in that live stream. It's right here. It's about a 16-gram nugget. Our stock hit $8 2 days later. So nobody can accuse me of not promoting. All right, but to get back to the serious side, look, we commenced proper advanced exploration starting at September of last year. We were focused initially right here in the Purdy's Reward tenement. This was the only tenement that was granted, and we had all the approvals to do drilling and trenching. So really our first effort was focused right here. Comet well had not yet been granted. We didn't have approvals to work on this segment here. We do now. All right, but that's where we started, in that little tiny piece of sandbox. The red is a trace of the conglomerate. It's dipping to the southeast, and it projects out underneath the greater basin in this direction. In cross-section, this is what we're looking at, a very shallow dip. Notice there's a vertical exaggeration of 3 to 1 here. If I tried to draw this at true scale, vertical to horizontal, it would look flat as a pancake. But this diagram was to illustrate the techniques we planned on using for exploring at Comet well. We were going to open trenches. This is our gold-bearing unit. We are also going to drill both diamond holes. These are PQ diamond holes, as well as large diameter RC holes to collect sample. We knew that the diamond holes were insufficient in terms of volume of material, but the RC holes we figured could provide us bulk samples. I'm going to show you what we discovered in the very early days there. First thing, we noticed there were a lot of rippled beds, sandstone beds between the conglomerate horizons. You see ripples like this in a place where you got water moving back and forth. You get symmetrical ripples. Okay, that's a tidal regime or a wave regime. So this is definitely shallow marine. The basalt immediately above the conglomerate is often pillowed. Haloclastite, breccia, definitely subaqueous deposition. Okay, so once again, these were telling us marine environment. This is our conglomerate horizon here. Initially, we dug trenches straight down across. We've since learned that's a big mistake out here, and I'll show you why later. Those are the sample drums we were using. We were just hiving off 250 kilos off the wall of these trenches at random and chucking them in a drum thinking, hey, we're really smart here. Let's ship them off to Nagrum. We'll get some answers. Didn't work out so well. I'll show you why. Okay, first thing we did is we got some samples with gold. That's actually a nugget. See that little halo of fine disseminated gold around the nugget? That was an eye-opener. Holy smokes, we're dealing with something different than I've ever seen. But it told me that the fine-grained gold in our sample was actually restricted to the area right around the nugget. That was actually a concern. I thought, uh-oh, this isn't like Beatons Creek. We don't have disseminated gold. It's actually still concentrated in this nugget form. Now, we did have lots of detrital pyrite. That's something we see at Beatons Creek. Quite comfortable with that. The conglomerate samples that we recovered are made mainly of mafic igneous rock. dolerite in particular. There's a little bit of gray wacky. You can see the nuggets. There's one, there's one. These are flattened nuggets that are encased in the sand matrix. And once again, right around them is a halo of fine-grained gold. So these are compositionally immature conglomerates, but they are class supported. The clasts are often well-rounded, so in that respect they're mature, but otherwise compositionally they're quite immature. The sand matrix, though, does have quite a bit of quartz in it. Okay, we exhumed quite a few nuggets, picked them apart. You can see they're rounded. All right, these are water-worn nuggets. They're encased in the sand matrix. Usually they have a chlorite halo around them. This dark green stuff is an iron-rich chlorite. And here you can see a halo of fine gold particles scattered around what is really a nugget that's almost dissolved entirely here. It's almost like the ghost of a nugget. In this case, it's a nice rounded nugget, in this one too. But these are the kind of patterns we saw. Right, so around November last year, we started to put together an exploration model, or a geologic model, I should say, of where this deposit might have formed. We think this was a delta system that was prograding out into the Fortescue Basin, but was occasionally being reworked by the ocean, just like at Beatons Creek. This happens to be the Yukon Delta. This is the Bering Sea. You can see the strand lines back here. So sea level rises across that surface. So it's a battle between the river and the ocean. But this is the kind of environment we envisioned for our deposits at Karratha. Here at Nome, Alaska, this is actually a submarine shot. This is a diver pointing at a gold nugget. That's the same setting we have at Karratha. The nuggets that we saw were basically in a transgressive lag surface, at least at Purdy's Reward, much like you see offshore Nome, Alaska, for tens and tens of square kilometers. There's gold nuggets scattered across the bottom of the floor, seafloor. All right, a little bit about large diameter drilling. We started this program thinking we were going to get an RC rig. Unfortunately, the company did not deliver an RC rig. They delivered a rotary rig with outside return. Effectively, this is a glorified RAB rig, and we tried to get consistent sample return, tried everything under the sun to get this to work, and we could not yield good, high-quality samples on a consistent basis. One sample would come out and be 40 kilos, the next sample would come out and be 400 kilos. It was a battle. We tried injecting water, a little bit of water, lots of water, nothing worked. Anyway, so we kind of gave up on this around the end of November. But it was a bona fide attempt. I would say we kind of licked our wounds and decided to step back and think about what we were seeing a little bit more. One of the things that really jumped out at us was when we were processing samples, some of these bulk samples at Nagrom, we noticed that the gold was universally coarse like this. Okay, so you can imagine like a couple of these nuggets, this one, you know, and some of these up here are big nuggets. They contribute most of the mass of the gold into to the sample, right? So the variability was just off the chart. Because of this, we brought in Simon Dominy to give us some advice. This was around the first of the year. And he stepped back and said, nope, you got to take at least 5-ton samples to get anywhere near a representative sample size. Now, the other thing I learned, okay, this was coming out of the field one night, I saw a prospector. This was a real eye-opening moment. So anybody that's in here who's a geologist, watch prospectors. They're very smart, okay? This guy here is named Mick Hennigh. Mick liked to come out every other evening, and he would mine a small area. It was basically an area where the rock had weathered a bit, and he would dig down to the magical layer with the gold nuggets, right? So he knew that about 0.7 meters down below surface, there was this horizon. And the way he did it was very systematic. He would dig a pit about 1 meter by 2 meters, and he would take it down in steps, just like in an open pit. So over about 3 or 4 hours, I watched Nick, and when he finally started getting down to the nugget horizon, you could hear the little beeps, beeps. Well, I didn't wait all night for him to dig the rest of the pit, but I said, Mick, in the morning, send me a photograph of what you got, and I'll buy whatever you got out of this hole. Next day I wake up, 5 in the morning, he's found 25 grams of gold, all in coarse nuggets. He was finding an average of an ounce a night every time he'd go out there. What I learned, though, is that to take bulk samples of this type of deposit, you have to take a consistent surface area. It's just as important as the volume of sample you're collecting. You know, think about that for a minute. If we were just hiving samples off the walls of our trenches, well, that was no better than drilling an RC hole. You got to take a consistent panel. All right, so that really changed my view, and based on what I saw here, I decided we better adopt a similar approach. Now, we did collect a number of bulk samples at Purdy's reward. Everything you see presented here are results from like 250 to 300 kilos weight samples. What we found is most of the gold is concentrated at the bedrock contact. This is the footwall. Very high grades, over about a half meter. Above that, yes, there's sporadic gold, but it all depends on if you get that nugget. If there's gold, if there's a nugget, you'll get a bit of gold. If there's no nugget, no gold. It's that simple. Same down in the basement. That's what we learned. All right, so we secured a test mill from SGS. This is actually an SGS Minerals yard in Perth. And we commenced exploration at Comet Well in February of this year. The two things we did differently, firstly, we drilled extensive core holes over the area so we could see what the subsurface geology was telling us before going into trenching. All right, before we had just gone in trench, and we didn't really know what we were looking at. But we decided to core drill first. The second thing we did, rather than just cutting slots in the ground, we actually cleared the surface of the ground, blew it off with high-powered air so we could see the rock. And once we did that, everything came into view. We could detect it. We could find the nuggets quite readily. We could see the geology. Things improved dramatically. Sampling. Here we are. We decided to sample a 2 by 2 meter pit like this. Once again, Mick Henry's approach. All right, we took it down in steps. So each slice is anywhere from 0.3 up to maybe 0.7 meters thick. But that's the new protocol we developed. You can see here, we've sampled several meters. This is the bottom of Comet Well. Comet Well's a little different than Purdy's. We actually see gold over about 3 or 4 meters at the base here. So these samples are currently at the lab. They're undergoing testing. We are going to publish some results in about 2 hours. So you can set your watch and look for a news release. First 2 samples went through the mill, and we have results, so you'll be able to see those. This is an upper gold horizon. This is a second horizon we found about 15 meters above the base. Again, though, we cleared it off, we detected it, we got good data. You can see we've core drilled right in the midst of this, so we know what's going on. Like, we have a better handle. We're almost like archaeologists in a way. We also detect, as they remove the overburden, they detect and find the nuggets in the oxidized material. Okay, so this is a section through the Comet Well area. Here we have two gold-bearing units. This is the lower gold-bearing unit. It's about 3 or 4 meters thick, like I said. That's where we're going to release results shortly. We found another unit above that. This unit is coincident with a tuff horizon, a very distinct marker horizon. All right, so we've been able to trace that, and lo and behold, we found that same horizon popping out in the creek bottom with gold nuggets. So this is quite a new, exciting discovery. It's our first ability to actually use a marker horizon to prospect. We are doing some studies. Alicia's doing some petrography for us. We're doing age dating. This is a study of the gold. This is one of the alluvial gold particles in cross-section. See the halo of fine gold around it? That's a secondary overgrowth. We've determined that there's an original alluvial nature to the gold. It's quite coarsely crystalline. And then a secondary event that's fairly fine-grained crystals, but also intergrown with rare earth minerals like fluorensite and monazite, and I believe xenotime is also present. Anyway, these are minerals, believe it or not, that occur intimate with the gold. We could probably date those. We can date that secondary event. Those minerals, as well as the chlorite that's often associated with the gold, those are probably forming in a submarine environment. So that secondary event, that halo of gold around the nuggets, is probably coming out in a submarine setting. This is a scanning electron microscope view of a gold particle here with secondary overgrowth and then the disseminated gold as a halo around it. All right, new discoveries. You can't swing a cat without finding a company out there who is promoting a new discovery. Look, some of these, I can tell you, like that's the gray, just trying to be cute. This is Egina. It's on our land. This is somebody who sent me a photo just to, again, to be cute. This is a guy who has a collection of nuggets from the Submount Row conglomerate in the East Pilbara. Very, very interesting. An occurrence I can't talk about because it's his, private thing. Yet another area. Okay, so the point is, this is not just a one-off thing. People are finding nuggets like this in multiple areas across the Pilbara. At this point, these are the locations that people are finding gold in the Submount Row environment. The blue dots are the basal conglomerate sequence. I could name all these dots for you. If you want to talk about these, it's best to do it over a beer. But I can tell you, when I get to Perth, there's about 4 or 5 people lined up to talk to me, and they each have a new occurrence. So one of the delights of working on this is that everybody's got a conglomerate showing or something has contacted me, even somebody this evening. Where'd he go? And we're learning more and more very quickly about the distribution of these occurrences across the Pilbara. Now stop and think about this. That's 50 kilometers down here at the bottom of the screen. That's 600 kilometers across. Okay, if this was just a one-off fluvial channel or something, not interesting. But to see this again and again and again and again over a huge area, and not just along the northern edge of the basin, guess what? It's popping out down here. Marindy announced discovery of gold at the Bellary Dome recently. Think about that for a minute. All right, is it economic? I don't know. We're gonna try to prove it is, but just on the geologic basis, this thing is widely distributed across the Pilbara. It's caused us to go think about going back to Beatons Creek. Here's our conglomerate at Beatons Creek. There's the gold from Beatons Creek. It's not nearly as big as that from Car Arthur, but it's still quite coarse. All right, and what we've learned is, wow, we got to take 5-ton samples at Car Arthur. So we asked Simon Dominy, what kind of sample should we take at Beatons? He said, at least 2-ton. Oh, really? Well, that means everything we've done to date at Beatons Creek is probably underrepresented the grade. We are now taking bulk samples at Beatons Creek. We expect to see improvements in the grade based on the initial information we have, probably twice of what we were seeing before. Significant component of coarse gold helps things in a big, big way. I'm going to leave you with one thought here. Back in 1886, in a little farm field in South Africa, a guy stumbled across an outcropping bed, this one right here, of conglomerate, pebbly conglomerate, but it had gold. It's a 1/2 meter thick. That's the main leader reef right there. That bed ended up producing 250 million ounces of gold in the Central Rand District. It's a 1/2 meter thick. This is in a park. It's in a pretty seedy part of Johannesburg. I got down in there. I was able to sample that. I got 16 gram per ton. Put it in perspective. 16 gram per ton over 1/2 meter. That's what gave the discovery of South Africa. Now this is the main reef underneath. It's about 2.5 meters thick or so. That grade's about 3 or 4 grams. It was not mine. This was the main target right here. Think about that for a bit. Very subtle deposits, but when you latch onto one, they can be very big. So we're hopeful we can replicate in our own way the deposits of South Africa. All right, with that, I'll answer questions.